Okay, let's keep it going with example 3 here, looking for dy dx, also known as y prime, of this equation that we cannot easily solve for y. So now I will take implicit differentiation here. This is one function here, 3y. Here, I'm going to look at this as being 13x multiplied by y squared. So when I take that, when I differentiate that, this is going to be product rule. And then here is its own separate function. So now that I've made a plan of how to visualize this problem as separate functions of both y and x, I can use implicit differentiation. So let's see, the derivative of 3y with respect to x is 3y prime, or 3 times dy dx, plus, now product rule. The derivative of 13x with respect to x is 13 multiplied by y prime plus 13x. Now what's the derivative of y squared? That's going to be 2y, but then chain rule, the derivative of y with respect to x, y prime, equals the derivative of cosine x is negative sine x. So now we need to isolate y prime. So the first thing I see is that this term here is the only term that does not have a y prime. So I'm going to move that over to this side. So I have 3y prime plus this becomes 26xy y prime equals negative sine x minus 13y squared. So now, how can I isolate y prime? Well, I can factor this out, GCF, y prime 3 plus 26xy equals negative sine x minus 13y squared. And now to isolate y prime, I will divide this term to the side. And in this step, I'm just going to go ahead and rename it what we're trying to find in that other form. dy dx is negative sine x minus 13y squared over 3 plus 26xy. So now we have used implicit differentiation. Let's try one more in the next video.